So I want you guys to take a minute to work on this warm-up. I'm going to come around and try to help you out. First off, let me just mention what we're doing today. I'm going to do a warm-up, and then we're going to take a quick look at the quiz that you took yesterday. And then we're going to look at some 6-4 problems real quick again. And then I'm going to give you time in class to work on 6-4. And then all of 6-4 will be due tomorrow. Okay? Sound good?
Yeah.
Nice short day today. You guys enjoy it?
I hope so.
So you guys should take a minute and try this out. I'm going to come around and see what you guys have. If you need a scrap piece of paper, you know where the paper's at.
My name is Dave. I'm the director of that town. This is a negative, and this is 1, and next one is the forward x.
Not today. It's a bad day. No one's going to be allowed up here after this.
I didn't see that.
Wait, why? Why? Because it's going to teach you to get ready for your teacher.
Well, then what,
We have a lot of work.
so then after,
You don't have to teach, right? Sorry. Okay.
It's like electronics, like in your shirt.
so like after the CN,
All right, so let's go ahead and go over this warm-up. Look, this is pretty similar to the quiz yesterday. Okay, so first off, looking at this point here, okay? If that's my coordinate, if that's my ordered pair, which one of these points or these numbers is my x? Jacob?
4.
4 is my x, right? So, if 4 is my x, I need to look down at my system and find my x's. Okay? And you would plug that 4 into those x's. Now, I had a question yesterday of whether if you plug the 4 into this x, does that make it the number 34? What do you guys think?
No.
So what does it do then? Spencer?
It would be
Negative 3 times 4, right? Because this is negative 3 times x. Now, so which other number is my y? JP? 8. So, 8 is my y, so I need to plug that into here. Now, if I plug those in, as you guys said, this would make 3 times 4. Negative 3 times 4. Plus our y value, which is 8, right? That's equal to negative 4. Now the question is, negative 3 times 4, what is that? Negative 12. Okay, good. So we have a negative 12, and then we add 8. Now, what does negative 12 plus 8 equal? Matthew?
-4.
Negative 4. Are these two the same number? Yes? Raise your hand if you agree. Obviously, all you gotta do is look at it, right? You see they're the same number. Good. Now, that looks good. So we know that this ordered pair works for this first part right here. Okay? Now we need to figure out whether it works for the second part. So, we plug in our 4 for x. Plug in our 8 for y. What's 4 plus 8? 12. Does 12 equal negative 4? No. So if 12 does not equal negative 4, the question is that ordered pair a solution to this system? No, it's not, right? So the answer is big old no. Right? So if you had no, good job. If you did not have no, or messed something up somewhere, persevere, keep trying, work through the problem, okay? If you have any questions, don't be afraid to come to me. What's up?
I think I got it.
You did good job. Yes. Alright, so I'm going to give you guys back your quizzes real quick, just for you to look at. And if you have any questions, you can ask me. We'll just take a couple minutes with this. What's that?
Might save you some time.
Oh, yeah.
Yeah, I'll help out.
Short hour.
Yeah, it's true. The only thing is I had two no names. One was Jacob, and the other one was guess who? Jacob.
Are you kidding?
I had two Jacobs with
Wait.
other names on the
Oh,
papers,
me?
so I need to know. Is that your handwriting?
Wait,
No, it's not.
let's see. Oh. I don't think it's so. Wait. Let me see the other one then.
Someone else that knows
No.
Jacob Andrew, come here.
No, what do the graphs look like?
Come here.
On the first
Do you
page.
have a graph on the first page?
Yeah, I have a graph.
Oh.
That one's yours then. That settles that. Thank you. Now I want you guys to look through your quiz, and I want you to see the markings that I put to try to figure out where you went wrong. Okay? Now there is an option for a retake on the quiz. If you want to retake the quiz, you just need to come talk to me, okay?
You know what? You know what? Quiet. I got 13 out of 12. Minus.
Did I already take the quiz?
Did I already take the
You can, yes.
Oh, you didn't take it. Cameron, you want to go to the hall?
Actually,
I bet I didn't take her to the hall.
I wasn't here yesterday. I wasn't here yesterday.
Oh.
I would like to retake the quiz.
So you get
With this one? How could that be?
this is mine. That one's mine. My name is Noel Butler. This is mine. This is you.
all right, Isaac, Elijah,
Can I take my
and
quiz today?
Cambry, can you please step out in the hall real quick?
Yes.
Can I take my quiz
We
today?
don't want to copy down these. Hey,
Can you
can I?
take your quiz today?
Yeah. This isn't
Can I
mine. This is
retake my
his.
quiz?
I didn't take it.
Can I retake mine? I did one simple wrong, and then I couldn't retake it.
Can you go out in the hall, please?
Hi, camera. Hey, mister, can I retake it? I just got that wrong.
Yeah, I'll let you guys know when you can retake it, okay?
It's gonna be like today. I can't retake it.
All right, so there was a question on number 5. Let's look at number 5 real quick. Okay. Can I borrow this? Just
I think I did pretty good on this one.
So the question is, how many solutions does the system have? Well, we have an x plus 5y equals 0. And we also have a 15y equals negative 3x. Now, the answer was infinitely many solutions. Who can tell me why or when you would have a solution that has infinitely many solutions, or an answer?
If the lines are
If the lines are what?
like
Right on top of each other, the same exact line or equation, right? Now, let's look at this top equation. If we want to get y all by itself, right? That means we have to leave y on the left side of the equal sign and move everything to the right. Right now we're just putting it in our y equals mx plus b form. Because once we have it in this form, we can look at the slope and we can look at the y-intercept and begin to inspect and investigate the two equations and see whether they're the same or a little different. Okay, so we'll look at that. So for this first one, what I want to do is subtract x from both sides, right? Because x minus x becomes 0. So, because that becomes 0, we also subtract x on this side. We're left with 5y equals negative x. Now, is the y by itself yet? No, so we need to get the y by itself. Tanner, how can we get the y all by itself on this equation?
15.
Divide by what?
15.
No. The green, in the green. How do we get y by itself?
Oh, you put it on 1. Divide by 5.
Divide by 5. Okay. So, why do we divide by 5? Jacob?
You get y by itself.
So you get y by itself, but 5 divided by 5 becomes what? 1, right? And 1 times y is just y, right? But if we divide that side by 5, we also have to divide this side by 5. But what's the coefficient in front of x here? Now remember, there's a symbol in front of x. We need to pay attention to that, Jordan. -1. So, what is our answer? Y equals -1/5 x. Good job, Jordan. Now, moving on to the next equation. Going back to you, Tanner, because you had it right the first time when I first called on you. What should we do to get y by itself here?
Divide by 15.
Divide by 15. So those become 1. 1 times y is just y. Equals, now we divided this side by 15, which means we have to divide this side by 15. Can we reduce -3/15? Raise your hand if you think we can reduce -3/15. Raise your hand if you think we can't reduce -3/15. Okay, some of you didn't vote, but we're going to look at it anyway. -3/15 can be reduced. Who can tell me what the reduced fraction is, Noah? -1/5. And it's -1/5, and we have our x left. Now the question is this equation the same as this equation? What do you guys think? Yes, it is, right? Because first, we don't have a y-intercept on either of them. And in addition to that, our slopes are the same. Okay? So, when it's the same exact equation, there are how many solutions? Infinitely many. Why? Because they're the same exact line. Okay? So they lay on top of each other. So, in a sense, they intersect infinitely many times. Okay? Because they lay on top of each other. Good. Now, let's go ahead and move on to the 6-4. I'm going to collect these quizzes back. I want you guys to have a scrap piece of paper, maybe something you did your warm-up on. And we're going to go ahead and take a little more of a look at 6-4, at substitution. Kind of touches on our warm-up a little bit. But we're going to look at the equations and see if we can find the solution instead of just having the solution and seeing if it works. Alright, good? Do I have all the quizzes? Alright, so again, I want to give you guys a little bit of time to work on your homework for any questions, because I know some of you don't fully understand substitution yet, but I want to continue to help you out with that. So first off, I want to try to give you a little bit more of a simpler system to try to use substitution in, okay? I'm going to give you y equals 2x and y equals 4x minus 2. Now the question is, what is the solution to this system? Alright? Now, you notice down here on the bottom, it's not saying something like 4x minus y equals negative 2 or anything like that. We're just looking at a substitution problem, okay? It's dealing with 6-4. Elijah, my comedian.
Hello.
We're just looking at 6-4, and we're looking at a substitution problem. I know you were gone, Camry, but maybe you'll pick up on this relatively easy, okay? So, if I know that equals means what? What does the equal symbol mean? Same as, right? So if I know y means the same as, what I'm saying here is that y is the same as 2x, because y equals 2x, right? Now I'm helping you guys out here a little bit, because the bottom equation says y equals as well. But here's a little bit of a difference in our substitution that we're doing. Y is not in the midst of all this where we just plug it into y, but you notice here that y is by itself on both sides, or both equations. We're going to say that y equals y. You guys agree that y equals y? Does 4 equal 4?
Yes.
Does 2 equal 2?
Yes.
So on and so forth, right? So if y equals y, and we know that this first y equals 2x. We know that first y equals 2x. We know that the second y equals what?
It's 2.
4x minus 2. Now what do we have here? Just x, right? We have just x's in the equation. So now we can solve for x, can't we?
Yes. Yeah.
So we can solve for x here. So if I want to get x by itself on one side of the equation, what should I do? How many say divide? Raise your hand. How many say subtract?
No.
Okay, subtracting. But if I'm subtracting, because I need to combine these like terms first before I divide anything out of them. However, do I bring the 4x over here or the 2x over there? Does it matter? Noah?
I'd say take the 2x over there so then you don't have negatives.
Good. Okay, so I want to take the 2x over here, so I subtract 2x from both sides. 2x minus 2x makes 0. 4x minus 2x is 2x. And I'm left with a minus 2. Now, I want to take this constant and move it over to the other side. What should I do?
Add 2.
Add 2. Okay? So you add 2 to both sides. So what's 0 plus 2?
2.
And we're left with 2x. Now how do I get x by itself? Courtney, how do I get x by itself?
Divide.
Yeah.
Divide. Why? Because I'm trying to turn this into 1. What's 1 times x? X. Good job. So if I turn this into 1, I also have to divide this side by 2 as well. So that means x equals what? What's 2 divided by 2? 1. Right? Now, if x is 1, I can go back to either of these equations. Okay? Let's take this top one, for instance. Y equals 2 times x. Cambry, if this is y equals 2 times x, what can I substitute in for x? 1, right? Because now I know that x equals 1. So, what's 2 times 1? JP? 2. Just simply 2, right? So, x is 1 and y is 2. So if they ask you what's the solution to this system by using substitution, this is a method you can use to find the solution, which means that this point when you plug these into x and y, they'll come out to be true statements. And like we saw in the warm-up, if it works for both of them, then yes, it is a solution. But in the warm-up, it wasn't, was it? It didn't work for both of them. Good. Okay, one more quick thing, just for something for real-life modeling. I want you to recall in the 6-4 digits lesson how we talked about alligators. Okay, and I'm just going to make up some figures here, but I want you guys to try this, and I'm going to come around and look at your work, and I want you guys to try to set it up the way that we just did, okay? If you have alligator 1 and alligator 2, okay, and you know that alligator 1 starts out at a certain length of 6 centimeters, and alligator 2 has a length of 4 centimeters, okay? But you know alligator 1 grows 1 centimeter per month, and you know that alligator 2 grows 1.5 centimeters per month. I want you guys to set up an equation for these two alligators' length and their rate of change. You guys should know how to do this. And then I want you to find at what point will they be the same length. What's that? Yes, yes. Yep. So I'm going to come around and watch you guys set these equations up. Alright, so let's take a look at this real quick. Alright? Who can tell me what the equation is for my first alligator? Elijah.
6 plus 1x.
Scroll down here a little bit. Y equals 6 plus 1x, which is just x, right? Because it starts at 6 centimeters in length, and then each month after that, it grows 1 centimeter. Who can tell me the equation of the second alligator? Noah?
Y equals 1.5x plus 4.
Excellent. Y equals 1.5x plus 4. Now, if I want to use substitution to find at what point they are the same length, if we say that x represents months, we're trying to find at what age they have the same length. So what should I do in this equation? Or for these equations? Spencer?
You need to make x plus 6 equals 1.5x plus 4.
Good. So you have x plus 6 equals 1.5x plus 4. Why? Because we know y equals y, so we take what they are equal to and make them equal to each other. Now, if we want to solve for x, I'm just going to go ahead and do this for you. X minus x is what? 0. You subtract x from this side, what are we left with? 0.5x, right? Left over with 6. Left over with 4. Now if I want to move the 4 to this side, I should subtract 4. Subtract 4. 6 minus 4 is 2. 0.5x left over. To get x by itself, I should divide by 0.5 because those divided by each other just make 1. Who can tell me what 2 divided by 0.5 is? Noah? 4. X equals 4 because how many 0.5s go into 2? 4, right? Good. So if x is 4, now we could stop there and just say that x represents the months, and we would say at 4 months, they're the same length, right? But just to find the whole solution, we'll just take x, plug it back into one of the equations. 4 plus 6 is what? 10. And our solution, if we needed to find it, would be 4, 10. Excellent work. Now, you guys have a few minutes left. I want you guys to get out your 6-4 homework, and you guys can work on it. 6-4 is due tomorrow. I will make an exception if I need to for those who weren't here. But now is the time to ask questions if you have any questions. What's that?
They took you.
The 6-4 homework on substitution?
Did you just give it to me?
No, we gave it this one. It looks good.
Oh, I think I've done that one. Is that the one that we did, like you said, just do 1 and then?
Yeah.
Okay,
I
yeah.
did all of them.
Yeah, I did all of them.
I'm pretty sure.
Alright guys, I want you guys to try to work quietly, please. No, I want you to stay in here, alright? Okay.
Look how many tests I have. There's not all of those.
I don't even remember what so my last
I don't know.